So our last so our last module for SRWE, troubleshoot static and default routes. Okay, so finally we are on the last module. Okay, so this module is very short. Okay, the objective is troubleshoot static and default route configurations. So we only have two topics included in this module. So packet processing with static routes and also the troubleshoot IPv4 static and default route configurations. Okay, so static routes and packet forwarding. So before dividing into the troubleshoot portion of this module, this topic provides a brief view of how packets are forwarded into static routes. In the figure, click play to see animation where PC1 is sending a packet to PC3. Okay, so just sending animation of packets. Okay. So the following describes the packet forwarding process with static routes as demonstrated in the animation. So the packet arrives on the gigabit Ethernet 0/0/0 interface of R1. Okay, then R1 does not have a specific route to the destination network. So this network here. So therefore R1 uses the default static route, 0.0 equal 0. Then R1 encapsulates the packet in the new frame. Okay, first it's analyze the MAC address, not the destination MAC address. Okay. Destination MAC address. Destination MAC address. Okay. Correct. Okay. So because the link to R2 is point-to-point link, R1 adds an all ones address before the layer 2 destination. So it's like the broadcast all ones. 255 or 255. So frame is forwarded out of serial interfaces. So the packet arrives on the serial 01's interface of R2. Okay, it arrives with this interface from this interface. So it's a point-to-point link. Then R2 then encapsulates a frame and looks for route to the destination. So R2 has static route to this network. Okay, using this interface. Now the R2 encapsulates the packet in a new frame. So because the link is R3 is point-to-point link, R2 adds an all ones address for the layer 2 address, destination address. Okay, it's a point-to-point link. So it's now the frame is forwarded out the serial interface, then arrives on the serial interface on R3. Okay, this interface, it's arrived. Now R3 then encapsulates the frame and looks for route for the destination. So R3 has a connected route. So this, the LAN is the network is connected to the R3 in the gigabit interface. Now R3 looks up to the ARP table entry for the IP address of the PC3 to find the MAC address for PC3. Okay. So if no entry exists, so R3 sends an ARP request. Now R3 encapsulates the packet in a new frame with the MAC address of gigabit Ethernet interface as the source. So the source MAC address is this interface here, and then the MAC address of PC3 as the destination MAC address. So the frame is forwarded. The packet arrives on the NIC interface of PC3. So NIC card, NICs. Okay, packet processing static route. So true or false, R1 must encapsulate received packets into new frames before forwarding them to R2. Okay, this is true. So router always encapsulates receives packets Now R2 will forward frames to R3 with on. Yes, it's also true because it's a point-to-point link. As you can see, R2 and R3. Now, what action will R3 take to forward the frame if it does not have an entry in the ARP table to resolve a destination MAC address? So, not have an entry in ARP table, so it sends an ARP request. Okay. So, for troubleshoot, IPv4 static and default route. Okay, common troubleshooting network changes. So when there's a change, network connectivity may be lost. Okay, so network administrators are responsible for pinpointing and solving the problem. That is all about. Then common troubleshooting commands, we have ping, trace route, show IP route, trace route, or trace route, show IP interface brief, and show CDP neighbors detail. Okay. Figure shows the topology used to demonstrate these commands. Okay, so first one is ping. So we're ping the, okay, this is an enhanced version. Okay, the extended ping. So it is an enhanced version of the ping utility. So it enables us to specify the source IP address for the ping packets. So we're pinging this address here from this address, which is this interface of R1, the gigabit interface. Now trace route. Okay. So this displays the route from this network to that one. No, from the router 1 to this IP address. Okay, so R1, so it goes to 172.16.2.2. So in this interface, then so the destination is 192.168.1.1, and then now I think the final is the 821.682.1. Okay. In this network, now show IP route, so displays the routing table. Show IP interface brief. So quick status of all interface on the router. And show CDP neighbors. Provides a list of directly connected Cisco devices. So from R1, we can also see the R3, even though it's not directly connected. Router transpage. Switch and IGMP. What is IGMP? Internet group. Multicast group memberships. Adjacent routers. Solve connectivity problem. Finding a missing route is relatively straightforward process if the routes are sorry. So for instance, the user at PC1 reports that they cannot access the resources on the R3 LAN. Okay. So this can be confirmed by pinging the LAN interface of R3 using the LAN interface of R1 as the source. Okay. We're pinging this source here from the interface of LAN 1. Okay. Again, we will use topology in the figure to demonstrate how to troubleshoot this connectivity problem. Okay, so ping the remote LAN, so 192.168.2.1, so which is this interface. This is the R3 LAN from the source. Oh, you can also use the interface as the source. Okay. Success rate is 0%, so we cannot ping the remote LAN. ping the next hop router. Success rate, so we have 100%. So we ping this interface here, 16.2. So it is success. R3 from 0/1. So it's also a success rate. Pinging from this interface to the interface of R1. 62.1. Okay, from this interface. So verify the routing table. Okay, so notice that the network is configured incorrectly. Okay, R2 routing table. So the routing table for R2. So the network has been configured using the hop address 192.168. Okay, so the routing table entered for this network, which is the LAN network for R1. So the next hop address is this one. So whenever so this one cannot ping the R3 because if it receives the ping request, then it replies, then it will go from R3 then R2, but the next hop address for this network will go back to the R3. So network R sent back to R3 instead of R1. Okay, so we need to correct the R2 static route configuration. So we use the no IP route to erase the command, or erase the route, and then enter the correct route. So verify new static route, throw IP route. Okay, so you can see we now have the from the R2 172.16.2. From this interface here. And the next hop address will be here. So ping the remote LAN again. So we now have the success rate of 100%. Syntax checker, troubleshoot IPv4 static and default routes. Send a ping from R1 to the interface of R3. So this interface. So ping 192.168.2.1. So the success rate is 0%. Test the next hop gateway by sending a ping from R1 to interface of R2. Okay, so ping 2.2. Okay, 100%. Review the routing table on R1, show IP route, and show IP route. Okay, let's see. One and two. R2 to reach R3 line. 2 dot from what? R2 serial should be 119.169. So we have the static for this network here, 192.168.2.0. This here, so it should be 192.168.1.1. So there is a incorrect 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 configuration. So 192.168.1.1. network. Okay. So the configuration mode, configure terminal, the static route on R2 to reach R3 LAN. Okay, IP route. Oh, this is for R1. Oh, it is correct. IP route. Lang. 0. Then the next address would be 192.168.1.1. Okay, let's see. So we don't have static route for that network. Oh, okay. We don't have entry for that network. Okay. Send the ping. So ping 12.168.2. Okay. We practice and quiz. So we have the packet tracer, our last packet tracer, and then last lab activity. Packet processing. So what did I learn in this module is packet processing with static routes and troubleshoot commands. Okay. So which sequence correctly identifies all the steps that are to perform when it receives a packet on internet interface. So the first one is the router will examine the destination MAC address. Okay, let's see destination MAC address. We have here to identify internet type field. The router then encapsulates the should be here. So it must first then encapsulate the internet frame for the router to see the destination IP address, which is the layer 3 address. So which 3 iOS troubleshooting commands can help to isolate problems with static route. So have ping, IP route, and show IP interface proof. Okay. Next is an entered static route to the internet LAN. Is to verify the exit interface is up. So we have show IP interface proof. So we can see if the interface is up or down. While the static route has been configured on a router. However, the destination network no longer exists. To remove the static route. So we have to remove using the no IP route. So which statement describes the sequence of processes using okay, so this then encapsulates the packet, select the appropriate path, and forward it to the destination hosts. Show CDP neighbor. What is the purpose of removing this command? So obtain information about directly connected Cisco devices. Next is so what two router commands we don't understand use to determine if the exit internet face was up, the exit address is available. So for the app interface is to show IP interface brief. Then the next app address is the ping. So we can check it's will get a reply. So network connection for this from the command. Okay. So when the network enters the command show IP route and the router is not in the routing table, what should the administrator do next? Okay, they use the exit interface. It's the next hub. So verify the serial interface is active and available. If it does not have a default route configured, packets need to forward to a destination that is not listed in the routing table. So it drops it. So what does the letter C mean? So it's directly connected to the router. Okay, I think that's it for the SRWE course. So this is our last module quiz. Okay, so we just need to wait for the exams. Okay. So I already took up this module, so not bad. My score is not bad. Okay, that's it.